this video, I'm going to teach you the exact, reputable way to tear a binary apart, find the secret data, and automate the boring plumbing so you finish reverse engineering challenges in minutes instead of days. And yes, once you know this, everything basically becomes open source. We'll go from tiny C programs to assembly patterns, use the tools that actually speed you up, and the debugger tricks nobody tells you, and finish with a one-click workflow that grabs the flag while you sleep. So stick around. Reverse engineering is not mystical detective work. It's just stubborn curiosity with better tooling. At its core, it's bottom-up archaeology. You're handed a blob of bytes, and your job is to figure out the human intent behind the machine noise. That means understanding compilers, registers, calling conventions, and the tiny habits every programmer and compiler leave behind. Start simple. Compile a tiny C program, open the binary, look at the hex, then open it in a disassembler. You'll see how 3 lines of C explode into dozens of assembly instructions and a parade of machine bytes. That explosion is your textbook. Learn to read it. Learn what move, add, call, push, return actually do, and why a compiler turns imp C equals A plus B into a sequence of moves, register loads, an add, and a store. Do that enough times with small examples and the patterns stick. Then you'll stop freakishly guessing and start recognizing. Use the right tools, but don't worship them. GDB will always be the king of low-level debugging, but it's raw and punishing. Add pwndbg, GEF, or PETA so it stops feeling like medieval torture. For nicer UIs and quick navigation, IDA and Binary Ninja give you decompilation and graph views that make complex binaries survivable. Remember, decompilers lie. They're chefs who try to recreate the recipe from the finished dish. Useful hints, but not the original source. Treat decompiled output as pseudocode that needs verification. Disassemblers are one-to-one, decompilers are educated guesses. Use both. Rename functions, comment obsessively, propagate your hypotheses through the file. The IDE should start to look like your brain. When you get a challenge or a suspicious binary, do this every single time. Run file to learn the format, run strings to sniff for obvious constants, run the binary in an isolated VM or container so you don't regret your life choices, then load it into your analysis tool of choice. Static analysis first. Skim functions, find suspicious calls, trace the control flow, and identify interesting globals or arrays that might hold secrets, like flag in CTFs. If the code manipulates an array and you see it passed into a print function inside a loop, you can be almost certain that the real data is assembled at runtime. That's when you switch to dynamic analysis. Set breakpoints, run and inspect registers. If the assembly loads the address of flag into RDX and never touches it again, get that RDX value in read memory. Know your debugger commands cold, dr, pxw, db, dc in Radare, gdb plus x/s in info registers in gdb. These are your reflexes. Practice with CTF-style problems, but don't treat them like trophies. Use beginner reverse challenges to learn the habits of compilers and obfuscators, then slowly ramp complexity. Focus on repeatable skills, reading assembly flow, spotting constant folding, recognizing standard library calls, reconstructing loops, and using breakpoints to confirm hypotheses. Automate boring part. Write scripts to extract strings, grep for common syscall patterns, or dump memory region. Learn to generate minimal test programs. Write the C that you think produced a snippet of assembly, compile it, and compare. That feedback loop is the fastest teacher. Don't skip dynamic analysis. Static tells you the plan, dynamic tells you the state. Memory inspection, registers, stepping instruction by instruction, and using strace, ltrace to see syscalls are how you confirm that your theory matches reality. Use regare 2 or R2 with -D and -AA for full analysis when you want a debugger that's actually built for reversing. Use breakpoints smartly. Set them right after loops or before exits to snapshot the final state, and then print the memory at the pointer registers you found. If you can't find a symbol, follow the registers. Compilers often leave the pointer in a register right before a print, and that gives you the address without hunting down symbol mens. Don't assume the decompiler is correct. Verify by stepping through the assembly. Always analyze binaries in an isolated environment, and if malware is even remotely possible, disconnect the VM from the network. Learn the basic Linux tooling, file, strings, object dump, readelf, strace, and ltrace. They are tiny, fast, and indispensable. Finally, mindset. Be patient and greedy for patterns. Reverse engineering is less IQ and more pattern hunger. The first few times, everything will look like chaos. Then you'll start spotting compiler fingerprints, common loop structures, and where the program builds its secrets. Practice every day with tiny exercises. Write a function, compile it, disassemble it, and ask yourself what the compiler did and why. Read other people's write-ups, reproduce their steps, and then do it without the write-up. CKFs are a sandbox and a roadmap. Use them. Don't if you're happy grinding it out. Either way, keep hacking, stay secure, and have a wonderful day.